Okay, hopefully you've had a chance to practice a few of those problems from Monday's video. So just getting familiar with the vocab stuff and learning how to connect and rewrite matrices as systems of equations or systems of equations as matrices. Today there's going to be a little bit more difficult content that we're going to work through. I don't want you to freak out too much. We are actually going to spend a decent bit of time next week doing some review practice problems and kind of finishing up and summarizing this unit before we actually move into an intro to calculus topic. Okay, so what we're doing today, try to focus and write down some notes, practice along with the video, maybe go back and watch this again. But know that next week we are going to do a lot more review of these topics because it's challenging. So we looked at matrices a little bit last video and last week, but we can do a few different operations just like you can with systems of equations. You can interchange any two rows in a matrix, so we can reorder. If our third row we want to make it our first row, we can do that. We can replace a row by a non-zero constant multiple of that row. What that is saying is you can multiply a row. Let's say we have this. So it's a 3 by 1. There's one of our rows in a matrix. You can multiply that entire row by, let's say, 2. Okay, so your new matrix then would be 6, 4, 2. You're allowed to do that. You're allowed to multiply it by a non-zero constant or a number of that row. And you can replace a row by the sum of that row and a non-zero constant multiple of some other row. Okay, so a lot of pretty confusing information here right now, but let's say we have these two rows. If I want to replace that first row, okay, I'm allowed to replace it by the sum of that row. So I can add row 1 plus, let's do 2 times row 2. So I can multiply row 2, okay, this second one here, by a number and add that to my very first row to replace my first row. So my new matrix then would be, your second row will stay the same, 1, 1, 2. And then I'm adding, this would be 3, 4, 7. Okay, so I'm adding row 1 to 2 times the second row and just replacing row 1. These operations are going to become useful as we try to get an augmented matrix, so go back to your definitions, into reduced row echelon form or just row echelon form for solving a system of equations. So we are going to practice a little bit using the operations for a matrix. We have this matrix here and we want to, so note it's an augmented, this would be an equal sign. We want to find a row operation for the following. We want a 0 in row 1. Okay, so we're mainly looking at these first two numbers. We want to see if we can get one of those to be a 0. So what I'm seeing here is that 2 is a multiple of 4. So if I do, let's say row 1, because that's the one that I want to change, and I'm going to add that to, actually I need to multiply row 1 by a negative 2, and I'm going to add that to row 2, okay, because if I multiply this 2 by a negative 2 and add it to the 4, that'll be 0. And then I'm going to replace that whole thing with row 1. Okay, so this arrow is just telling me where this operation is going to come into play. It's going to replace row 1. So I'm multiplying all of row 1 by negative 2. So let me just do that first operation. I have negative 2, negative 4, and then I have a negative 10. Then I'm adding this row here to row 2, and I'm going to replace that with row 1. Okay, so negative 2 plus 3, that's 1, 0, negative 3, and then 3, 4, 7. Notice even though I was using row 2, I didn't change any of the numbers in row 2. Okay, so this first step here was just doing a negative 2 times row 1. This second step was doing the negative 2 times row 1, which we had already done, and adding that to row 2 in order to equal my new row 1. Okay, a lot of very different symbols, a little bit confusing to understand this. You will have to practice this concept a decent bit. So let's look at option B here then, having a 0 in row 2. Okay, so I'm going to use this, let's choose a different color. We're going to use this matrix. I now want a 0 in row 2. Okay, so I'm going to get this 3 to become a 0. So in order to get that to be a 0, I need to have a -3 times row 1. I'm going to add that to row 2. Okay, so all of these operations I'm doing right now are replacing row 2. So I need a 0 in row 2, column 1. So I need that 3 to become a 0. So let's do -3 times row 1. That's your first step. -3, 0 doesn't change, 9, and then you have 3, 4, and 7 again. Now we're adding that first row to row 1, or row 2, sorry. Okay, so this will become 0, 4, 16. Okay, and then our row 1 is still going to stay the same in this original box up here for the matrix. So even though we changed it in this step, we're not replacing it. So row 1 has to stay in the original format there. Okay, so this step right here is just kind of your intermediate step to show how it's all changing, but I'm not replacing row 1. Okay, so my row 1 here has to stay the same that it was up here in this matrix, because that one is not being replaced. I'm only replacing my row 2. Okay, so I got a 0 in row 2, column 1. That's awesome. Okay, we are not going to do part C for now. Okay, we're going to actually move ahead to a little bit different problem. So here we have a system of equations. We want to write the augmented matrix. So we're just writing this as a matrix. You guys should be pretty comfortable with this so far. So I always do what's on the other side of my equal sign. Then I have a 1, 1, and a -2, a 0, 1, 3, and a 0, 0, 1. Okay, hopefully you noticed that this is a row echelon form, meaning we have 1s here on our diagonal. Okay, it's actually triangular form too, but it's not reduced row echelon form. We don't have just all 1s on the diagonal, then everything else is 0. So we are going to take that matrix. Let me write that again. Okay, so there's our matrix from the previous slide. It's kind of written small, but hopefully if you're taking notes, you just have it at the top of your page. We're going to do all 3 of these operations. So first thing we want to do is we're replacing row 2. So this is the one that we're replacing. We just want to kind of keep that there. But in order to do that, we're going to do -3 times row 3 and add that to row 2. Okay, so let's write row 2. We're just going to keep it out of the matrix form for now. 0, 1, 3, -8. And then -3 times row 3. So -3 times 0 is just going to be 0. -3 and 9. Okay, so here's my row 3. Here's my row 2. And then we're just going to add those together. So 0, 1, 0, 1. This now will become my new row 2. So this new matrix, every other row stays the same, 1, 1, -2. Row 2 now becomes 0, 1, 0. And then row 3 stays the same as well. Okay, so row 2, we actually have row 2 in that reduced row echelon form. Everything except that middle value there, which would be your second row, so we're looking at the second column. Everything else is 0 except what it equals, and then that very middle term. All right, let's look over here now at the other operations that we have. we're looking to replace row 1. So now we're changing our first row. Everything else is going to build off of this green matrix. So we are doing row 1 minus row 2. So let's write those again. 1, 1, negative 2, 6, minus row 2. Now we're using the new row 2 that we just formed. So we have a 0, and we're subtracting it. So all of these numbers now become negative. Negative 1, 0, negative 1. So because we're subtracting, I just took my row 2 from this green matrix, and I just put a negative in front of all of them. For the zeros, it doesn't really matter, but the ones it will. So my new row 1 becomes 1, 0, negative 2, and 5. Okay, so my new matrix then, 1, 0, negative 2, 5. So just that first row changes. Everything else I'm going to pull right over from my green matrix. Okay, then we have one more operation. Again, we are going to replace row 1. Okay, we're going to do 2 times row 3. So again, we're pulling from the blue matrix now. So we're pulling from our most recent matrix. 2 times row 3, so that's going to be 0. So 2 times row 3 is 0, 0, 2, negative 6. And then we're adding that to row 1, 1, 0, negative 2, and 5. I'm going to add those together. Okay, and this now becomes our new row 1. Okay, and all of those operations that we just did made this matrix into reduced row echelon form. So you have 1s on your diagonals, and everything else is 0 except what's across on that vertical line. Okay, if we were to rewrite this now as a system of equation, your first row gives you x equals negative 1, your second row gives you y equals 1, and your third row gives you z equals negative 3. So our goal with reduced row echelon form is to get it so that we can just look at the matrix and figure out exactly what the values of our variables are. Okay, so if you look at your previous slide or look back in your notes, we started out with this system of equations, and actually without realizing it, we solved this system of equation using matrices, and we figured out that x has to equal 1, y equals 1, and z equals negative 3. You guys have practiced doing this with just normal equation and different operations with that, but we are going to actually use matrices in order to figure out the system of an equation. Okay, if you want to write this problem down, go ahead. We will be solving it, but I'm going to solve it in the next video, so you'll have to look at part 2 for this one. But go ahead and write this down and see if you can solve this using a matrix. If not, just log on then to watch the second video and get the rest of the notes for this.